How you doing, everyone? My name is Wesley Souza, and my project is on exporting and importing through MATLAB on 3D models. Okay, so my project goal and description would have to be to find ways to create objects on MATLAB coding, as well as to import and export it out as an STL file for 3D printing and modeling as well. So why this project? So the reason for choosing this project is to utilize both my classes, as in um, multivariable calculus, which is 3D Calc 3, is going over basically X, Y, and Z coordinates, polar coordinates, and 3D models itself. And I also want to incorporate my engineering computations class, which is going through MATLAB to plot as well as create different images for statistics, for various different data analysis. How you doing, guys? So what we see here is I plotted a 3D plot, a cube, a red cube. Okay, so we're going to walk down the code, see how we did that. So as you look on the top line, we see a equals 1. A equals 1 is saying that the variable a is equal to 1. As we go down, we see vertices. The vertices are the edges of this cube. Okay, so each edge or each point on it is going to be here listed on vertices. Okay, so as you see 0, 0, 0, that would be the origin. So that is a point, and also the edge of this cube. All right. And why we did A is for the reason that we can scale it however big or however small we so want. As I said 1, so 1 inch. And so if I said 4, if I replace A equals 4, then it'd be 4 times bigger. All right. If we go down, we see faces, as I called it. This is just tracing around it. So as we said 0, 0, 0, that would be 1. And as we do A 0, 0, that would be 2. So it is imagine it as drawing up a square to be a tracing point to point and drawing up a square. So that is how I make the faces. Go down, we're seeing H equals patch. That is basically just patching and everything up nicely and forming the box so it can have a good visual for the consumer, person, onlooker, boss, whoever's looking at this plot. Okay, as well as materials, lighting to nice and prep it up plot. Underneath, we see trifaces as for preparing for triangulation. Triangulation is necessary when you want to convert to um, STL file. Triangulation will create triangle faces, triangle nodes, so it can all be converted into a file. Okay, guys, so this slide is just showing you that it's compatible with Bamboo Labs A1 printer, as it has been tested out and 3D printed here. Alrighty. Looking at this slide, we can see that there are two plots, sorry, on the top right. They are both a one piece, but with two smaller compartments on the other side. So one is showing a shaded view, and one is showing a more clear view to see the hidden geometry or hidden shapes. Okay, this was created in SolidWorks as it was designed, and then soon to be, we are going to import it into MATLAB. Alrighty here, guys. So as we see here, we have the shaded piece. Okay. And we were going to talk about the differences that make how the shaded piece and the clearer piece go. They're both the same part, and we're going to first start off the code by naming it tr, which is the variable, equals stl read, just calling the function that is read this stl file, so we can convert it into, so MATLAB can understand this. Okay, if you look down, we see faces and vertices that we're all too familiar with, and we're saying tr, which is basically try. These are what we need. Okay. If you look underneath, we see the OK, which is the variable I call for import geometry. So we import it as we are able to read it now. And once it's in our work folder, I believe, in our little library in MATLAB, we first call PDEG plot. And then we have face alpha 0.3. The 0.3 is the depth that is shown. So compare it to a higher number, it would show a more clearer view of the part. So as for our other clearer piece, it is around 0.7, so a higher, um, so a much more clear view clear to us. Okay, as well as we label the x-axis and z-axis here for understanding and view and lighting. Plot it so you are able to edit and see here in MATLAB. Alrighty here guys, now we're going to be talking about combining and editing STL files. So since we know how to import them and we also know how to create them in MATLAB, we are now going to try to combine them together to form a new different STL file. So we can go forward making 3D models through MATLAB. Alrighty here guys, for this code, we first in the top line, we get to see STL read. Basically just read our compartment that we've previously seen that we've imported. Okay. And we get to see the points as well as the connectivity of it. So creating the faces is the connectivity. Okay. If we look down, we're going to see a row of matrices of numbers. So V2, Q2, and these are just creating the cube. But this time we've made it longer and as well as shaped it a little bit differently. Okay. And as we go down, we're just shaping it up correctly, finding the right points that we want to do it, and tracing over to make the shape. Okay. You're also trying to make it into triangles. Okay. So it can be, so when we do triangulation on the creating piece, it will show to read it and be able to efficiently change over. Okay. As we go down, this is plotted as a trisurface instead of a PDEG plot or as a patch. As a patch, it would just patch it up nicely. It doesn't need to have triangles. As a trisurf, it is just making making triangles and forming different faces onto it. Okay. And then of course labeling, presenting, and we finally have our merged piece. Thank you very much for listening and have a good one.